Hello students, today this is our first lecture of class 10 science chapter 1. Chapter 1 name is chemical reaction and equation. So I have written a few things over here and it is for a very quick revision of some important concepts of class 9th. That means this chapter which requires some prerequisite knowledge from you which you have learnt in class 9th. So first important point which you might have learned earlier is the concept of valency, and second one is molecular formula. So let's just revise what is valency. Suppose the oxygen we take and hydrogen we take. Okay, the atomic number of oxygen is 8 and atomic number of hydrogen is 1. So now we will draw the electronic diagram for oxygen and hydrogen. See how? This is nucleus, this is first shell, you name it K. This is the second shell, you name it L. Now we all know that first shell have only 2 electrons. Means it has a space for only 2 electrons. Only 2 electrons can be filled in there. Now moving to the second shell. If you minus 2 here, only 6 electrons are remaining. So you need to fill 6 electrons in the last shell. Why all the 6 are we filling in L shell? Because we already know that this shell must have a space of 8 electrons to be filled. So we see that we only need to fill 6 electrons. That means these can easily be filled over here. Okay, let us fill now 6 electrons. First here, second here, third, fourth, fifth and sixth. Now if you see, is still the place is vacant for 2 more electrons, right? Suppose one place is here vacant and second place here is vacant. Now till oxygen gets these 2 electrons, it will remain unstable, because every element in periodic table, not just only oxygen but every element in periodic table wants to attain noble gas configuration, which means they want to have a configuration in which all the electrons are completely filled, all the shells are completely filled, so that they don't need any further reactions or equations to independently exist in environment. So oxygen, to become or to attain a configuration like noble gas, it needs to fill these 2 spaces also. So from where it will get these 2 electrons, these 2 vacant electrons, because it has a space, so it can take electron from other elements. So what happens? Oxygen either will take 2 electrons from one element or 2 electron from 2 different elements. Okay. So what does this means? This means it has 2 places vacant and oxygen wants to fill these 2 places. So it's totally depend on oxygen to which element with it wants to engage itself. Suppose he wants to take 1 electron from hydrogen and another from sodium, then it's totally depend on oxygen, right? So either it can take 2 electrons from one element or take 2 electrons from 2 different elements. Now see how. writing something important which I write here, you can pause the video and can write it. Okay. Suppose if I take two different elements, sodium atomic number 11, and if you make the configuration, it becomes like this is nucleus, this is first shell K, this is second shell L, and this is another shell M. Let us see if we need M shell or not. Filling 2 electrons here, because this is the limit of K shell, it can only have 2 electrons, so I have filled 2 electrons. Now minus 2, we get 9 electrons. So out of 9, I can fill 8 electrons in L shell, because L shell have the space to establish 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. All 8 electrons have been filled. Now 1 electron is still remaining and it will goes to M shell. Okay. From 9th class, you have already read about the Bohr's model, which says that K, L, M and shell should have 2, 8, 8, 18 and further 18, 18 configuration. So if we go with this, we know that in M shell also 8 electrons must be filled. But you can see there are 7 places vacant. This M shell has 1, 2, 3, 4, 5, 6, 7. 7 places vacant. Now we know that if you take something in large amount, you will get more of the lone pressure. You know, taking something from someone makes you feel like you need to repay this someday. So it's a kind of negative thought. And this will take more energy for sodium to gain 7 electrons. So instead of gaining 7 electrons, sodium prefers to donate this only electron. And when it donates this one electron, suppose this one electron goes to this one place of oxygen, so even this electron is not here and this place also becomes vacant. And now sodium, another figure for sodium, another electronic diagram for sodium becomes like these 2 electrons, this is nucleus, and this one electron with 8 electrons. This is K shell, this is L shell. This is the diagram of sodium after removing this electron. Why this happened? Because when you see that there was 1 electron only and sodium has even donated that 1 electron, so there is no more electron left in this shell, so there is no work for this shell to be in the electronic diagram of sodium, right? We only draw the cells which have electrons. The shells which do not have any electron, I would withdraw that. So now you have understood the concept that sodium from the outermost shell has donated 1 electron to oxygen. Now oxygen has 1 electron thanks to sodium. It has now 1 electron from sodium, and I just make this with this so that there is no confusion from where that one get. And this is the M shell. So right now we are not going to study the configuration, so I have removed that and also removed this. This is the basic mathematical calculation. You can do that. Now another element I can take, suppose hydrogen. Atomic number 1, that means this is nucleus and this is the 1 single electron it has. This is the K shell. Only 1 electron is present. So hydrogen actually has dual nature, because we all know that this K shell can have 2 electrons, space for 2 electrons. Therefore hydrogen also tries to get 1 electron or to either remove this electron. Means hydrogen wants to either remove this so that there is no shell, but it never happens. And hydrogen also wants to have 1 more electron so that at least 1 shell octet is complete. Okay, but Right now oxygen is in hydrogen is in this position. So what will hydrogen do? Hydrogen will not completely give this electron to oxygen, because it will give, if it will give this electron completely to oxygen, it will lose its existence. So what will it do? It will actually share the electron with oxygen. So I can make it from, I just made it here, and now you can see this electron of hydrogen is being shared with oxygen. Now I am saying that this is being shared, but in a very usual and basic and easy language, I will just say that oxygen has attained its two vacant places, completely filled its two vacant places by taking one electron from sodium and one electron from hydrogen. So now octet of oxygen has been completed with the help of sodium and hydrogen. So what will you write here? How the compound will be formed? Let's just remove all this. Oxygen was in need of two electrons. So need always is a negative thing for us, because we all want to become a fully filled person, right? So it will get a minus sign, and then sodium plus 1, and then hydrogen plus 1. So this one goes here, this one goes here, and one of the, it can be written as minus 1 and minus 1, right? So 1 minus 1 goes to here, and 1 minus 1 goes to here. So the formula will become NaOH, which is a very familiar formula for you. You have read this almost everywhere. Sodium hydroxide, the strongest base, right? So this has become for the molecular formula for it. Now I hope you have understood the concept of valency and forming the molecular compounds. Now what I have said, the second statement, that oxygen can also attain those two electrons from one single element. If suppose I take only sodium, okay, and now we know that sodium has one electron in its outermost shell, right? You remember in M shell it has only one electron, and that was given to oxygen. So sodium has one only electron in the outermost shell, and suppose if we take two sodium atoms with one electrons in their outermost shell, and these two electrons are given to oxygen, okay, because oxygen is in need of two electrons, okay, and it is giving one electron to attain the noble gas configuration. So the formula will become something like Na2O, right? Because two of the sodiums are needed to complete the octet of one oxygen atom. It can also be written here as oxygen minus 2, sodium has plus 1. So this minus 2 goes to N, this plus 1 goes to oxygen. So it can be written as, but in writing chemical formulas we don't write the symbols, we just write the formula, and it is more correct to write it like this, Na2O. This is called sodium oxide. So here I have showed you that oxygen can choose to combine with two different elements to complete its octet, or oxygen can also choose to only combine with one single element to complete its octet. In both the cases, the final result will be the completion of oxygen's electronic configuration. And not just oxygens, here sodium is also getting a stable configuration, because sodium is donating one electron from the outermost shell, now removing the M shell, and it has only K and L shell which are completely filled. So it is also good for sodium. Now if you see, I take another example of H and O, which is a very basic example, you all know about that. Oxygen is needing two electrons, hydrogen has one electron. So hydrogen has given one electron to oxygen, and therefore and oxygen, because it is in need of two electrons, so it will uh, take two hydrogen atoms to complete oxygen's octet. So it will be like this. This will be the diagram, and the formula will become H2O, because this 2 will go here, this 1 will go here, and it will be written as H2O1, but it is better to write it H2O. Symbols are not used in writing molecular formula. So here even the octet of hydrogen is also completed. I would say not octet, but the shell limit is filled in hydrogen also. So hydrogen has also attained the noble gas configuration, and oxygen has also attained the noble gas configuration by sharing each other's electron. In this case, neither the oxygen is taking the electron from hydrogen completely, neither the hydrogen is donating its electron completely to oxygen. It's being shared here. So this is a covalent molecule, but it behaves like polar. So this was the concept behind molecular formula and valency. I hope you all get this. To form molecular compounds and to find the valency very accurately, very precisely, you must need to know the atomic number of the elements, so that you can know how many electrons are there in last shell, so that you can actually determine that out of those electrons how many of them are gonna participate in any chemical reaction. Until unless you don't know the configuration, until unless you don't know the atomic number of the element, it will be little hard for you people to accurately calculate the valency or accurately make the molecular formula. Okay students, so I have written here some very important ions with the symbol and charges over here. You can write it down and learn it for future use of chemical compounds. It will be easy for you to make molecular formula for it, because these are the very important and very usable ions. Okay students, so I have written here some very important name of ions and the charges over there. Here the +1 charge represents that it has been donated one electron. There's plus charge means donation of electron. +2 means donation of two electrons over here. Now there are many more ions which I'm gonna write here, and you must have to copy it in your notebook so that it will be easy for you to make molecular formulas. Rather than remembering the lots of atomic number, you can just remember the ions and their charges with the symbol, and you can easily make molecular formula out of this. So pause the video and write down these important chemical ions in your notebook, and I'm gonna erase them and write the new ones. Please pause the video and write it down. Okay, another elemental ions are magnesium, its symbol is Mg, charge is +2. Another one is actually more precisely, if I say, this is not the charge but this is the valency, because there is difference in writing it like this and writing it like this. So this represents the valency or oxidation state, and this represents the charge. So if you want to change the heading, you can write there valency instead of charge. And because I have already given you many element names before, so I I just not write plus here, I will make plus here, and now this is the charge. Another important element is manganese. This is iron, this is also iron. Why we are calling it iron? Because these have donated electrons. You have heard about cation and anion. Okay, anions are those which take electrons and cations are those which donate electrons. So it is similar thing here also. If I don't write here 2 plus, then it becomes magnesium atom, and if I write here 2 plus, then it has become magnesium ion. So manganese ion, it is Mn3 plus. Mn3 plus. Further is zinc. Zinc is Zn2 plus. Then aluminium. This is Al3 plus. Then ferric. Ferric ion, and it is Fe3 plus. Moving to some anions, bromide is important. Bromide ion, it is Br minus. Actually it is minus 1 minus, so we don't need to write 1, it is already understood, so we only write minus there. Now chloride, it is written as Cl minus. Fluoride, it is written as F minus. Iodide, it is written as I minus. Please pause the video and write these names and the charges on the ions. After completing the list, we will practice some questions. So I'm going to erase it now. Okay, some more important ions. Oxide ion. Oxide ion is O2 minus, as we have already seen about oxygen in the valency concept. Now sulfide ion S2 minus. Nitride ion N3 minus. Phosphide ion P3 minus. And after these are all the monoatomic ions. That means these are made from one atom only. Oxide is made from oxygen atom, sulfide is made from sulfur atom, nitride is made from nitrogen atom. Similarly, phosphide is made from phosphorus atom. Now we will consider some more ions which are not the monoatomic ions. They can be diatomic or polyatomic ions. What does that mean? This means that they have been made from 2 or more than 2 atoms. Suppose I write here hydrogen carbonate ion. Hydrogen carbonate ion. So if you see here it is hydrogen, and in carbonate ion there is carbon and oxygen. So it is made up of 3 atoms. So this is a polyatomic ion. Okay, you don't need to write here HCO. I have just written here to explain you the thing what is polyatomic ion. So polyatomic ions means that they are made up of more than 2 electrons. Hydrogen carbonate ion, this is also known as bicarbonate ion. And its charge is HCO3 minus. HCO3 minus. Another polyatomic ion is hydrogen sulfate. Hydrogen sulfate ion. It is also known as bisulfate. And its charge is HSO3 minus. Sorry, I have mistakenly written here. It is sulfate, so its formula is SO4 minus. Okay, further moving to next important element or ion is hydroxide ion. It is OH minus. So how does this charge came here? OH minus. Please pause the video and write the names and charges of the important ions. I am erasing it from here. OH minus. Oxygen was having in need of 2 electrons and now it is combined only with 1 hydrogen. So it is the sharing of only 1 electron. Still the need of 1 electron is remaining. Therefore this charge came minus in the whole thing. Okay. Another polyatomic important ions are nitrate ion. Its charge is NO2 minus. Another is permanganate ion. MnO4 minus. Acetate ion. CH3COO minus. Hydrogen sulfide ion. Hydrogen sulfide ion Hs minus. Ammonium ion. It is NH4 plus. Why here NH4 plus? Because we have already studied that nitride ion has 3 minus charge. That means if it can combine with 3 hydrogens giving 1 electron to it, its minus 3 charge will be balanced. But if 1 extra hydrogen is coming to it, then there is no more negative place, no negative charge left over nitrogen to balance this hydrogen one extra electron. Therefore, plus charge is acquired by this whole molecule. So it is NH4 plus ammonium ion. Carbonate ion, CO3 2 minus. Sulfate ion, SO4 2 minus, which I have mistakenly write here in somewhere, SO3. It is SO4 actually. Dichromate ion, it is Cr2O7 2 minus. Cr2O7 2 minus. Phosphate I have not written here. Okay, please pause the video and write all these names also. Okay. Let's erase them. Next important polyatomic ion is phosphate ion. You can also call it diatomic ion because it has only two atoms, phosphorus and oxygen. PO4 2 minus is the charge, and then lead fourth ion, because lead has two valencies, one it has +2 and one it has +4. Therefore +2 is known as lead 2 and +4 is known as lead 4. It is also have another name, plumbic. So it is Pb4 plus. Okay, that's the end of the list.